Welcome back, everybody. Today we're looking at this Crown PE 4500. I know I got the brake off. I know I got it up in the air. I'm not here to look at all the fluid that's right here quite yet. It's got very slow travel, almost like the motor's struggling. There's a couple things that could lead to that. I'm gonna get right into that. But first, why don't I just show you? Let me come on over here. Take a look at this right here. Also, can you hear that? That's not supposed to sound like that. So one, there's a couple things I think it could be right off the bat. One is why I took off the brake drum. I wanted to inspect it. The next thing could be it's out of fluid. If it's out of fluid, the gears could be grinding. They could have grenaded, and now they're creating their own resistance. The next could be they drove over plastic. There is plastic in between the drive tire and the drive unit. That's normal. I expect some. But if it's sucked in plastic, it could be creating resistance, not letting it spin. Or it could be a wiring motor controller issue. These wires, when I was bringing it into my shop, these wires did get up to over 100 degrees. I think my temperature gun read 112 max. That's not good. Alrighty, now one of the very first things I want to do is just resistance check these motor wires that come right to here. Resistance creates heat and also would create a bad connection between the motor, which is on the other side of here. It'll create a bad connection between this motor and this module. So I want to remove one side, doesn't matter which. I want to remove one side of these connections and do resistance check across it. That will tell me if these wires just went bad. That'll create the heat, that'll create the runnability issues. All right, so that one is W. W goes up here. Those are still tight. Connect my meter leads. When it comes to checking resistance, you always want to disconnect one side of the circuit. If I left this connected, I could check here to here. Let's say there was a break somewhere in this wire. If I checked here to here, it could go through this motor, connect to one of these other wires, go all the way back, go through different connections in this module and give me a reading. Granted, it's not gonna, there's a chance it won't be a good reading, but it won't show me that there's an open either. Resistance checks. So there's two different main style of checks I like to do. One's resistance and one is voltage drop. Resistance, you disconnect power to one side of the wire. You unplug the battery, you disconnect it from any power source, you turn everything off. You disconnect one side and you check from one lead to the other. That way you know you're only checking that one wire. Then there is voltage drop. You leave everything connected. You take one lead and the other and you touch them just like you would resistance. But with that, it tells you how much voltage is dropping from one end to the other. If you get a negative result, that's just reverse polarity. Drop the negative, that's your answer. Or you could swap your leads if you're, a stickler about it. But for now, I'm doing resistance. 0.2 ohms. That is reading good. That doesn't mean that it is good, because with no load, that's why I like voltage drops. Resistance is checking it with no load. Load could change everything. But for now, as a starter, with how hot this was getting, I wanted to do this just to be safe. For now, that one is fine. .5, 0.6, not bad, not good. 0.6, 0.5. Yeah, let me voltage drop these connections. Point 1, point 2, that is not bad. Point 3, not bad. Do you hear that popping? That leads me to think that it's the plastic that got sucked in. Not to mention it's not going any higher than 0.3. So I think for the next thing I'm going to want to do is I'm going to want to remove this drive tire. And I'm not getting a good visual in between. I think I want to remove this drive tire and see if there's any plastic that got sucked in that could be creating issues. I do see some plastic inside and that can create issues. And then check fluid levels. So yeah, I'm going to go ahead and I'm going to remove this drive tire and I'll bring you guys back. Alrighty, now I went ahead and I dropped out the drive tire. The issue is still present, but it led me to something else. I think the gears internally are broken. When I dropped it out and I pulled out the axle, because I didn't know if it was the axle as it was going, because they're splined. Here. This is the axle that holds the drive tire. As you can see, it's splined. I've seen it before to where the splines have broken off and it's caused this issue. I didn't know if that was one of it. Now that I removed it, I know that those splines are good. I know that that's not the issue. I know that this would not create that sound. I know the wires would not create that sound. To a certain degree. If it was sending out the wrong pulses at the wrong time, the drive motor could create something similar. Or it could be the gears in here are all messed up. I'm going to drain the fluid, see how shiny it is, and we'll go from there. I mean, I might have to drop out the drive unit. We'll see. But for now, I have my morning meeting I have to go to. I got to go use the restroom. So I'm going to take a picture. I'm going to post it right above where this unit is right here of what the gear oil looked like. So stay tuned for that. Welcome back, everybody. I just had my morning meeting, had a little snack, and now I'm back on this unit. I drained the gear oil from the drive unit. I didn't like what I saw. It's enough that it could be what was causing it, but there's also a chance that it's not. There wasn't enough metal shavings in there to where I'm like, oh, it's definitely the drive unit. It's definitely a gear. It was enough to where it's like, that's not the best, but I've seen worse. I know I'm jumping around. I don't. The drive unit's heavy. I don't want to drop it out unless I'm 100% sure that that's the issue. So what I'm going to do now is I'm going to remove the drive motor and put it on my bench and spin it by hand. If the clunking is in the motor, I will feel it. If it's not, if that spins smooth, then I know it's the drive unit and I do got to drop it. Come on over here, disconnect this encoder. Ow, that fell right on my toe. These are my most used snap ring pliers. I got them for like $20 off of Amazon. Saved my butt many times. with this specific type of adapter, you got your keyway bushing. There's also a split here. What you could do with that split is if you take a pry bar or something, very gently, if it wants to go in. This is one of those things to do as I say, not as I do. Don't use screwdrivers as pry bars. I don't know if you could see how that is opening up. I can just pull it right off. That is the seal I was talking about that is leaking. That created all that mess down there. I'm going to put you guys back up. All right, now that you're back, I'm going to remove this key something. Forget the name. Whatever it's called, I got to remove it. Yeah. All right, let me get my face. It did mangle it up a little bit, but that's cleanable. All right, so these teeth look good. That's what I was wondering, if these teeth were shot. But they look fine. Let me get it up on here. I was worried about these teeth being eaten. They appear fine. Everything looks fine to me. And I'm spinning it. I don't know. I'm going to check this side now real quick. This is what it looks like without the motor. In case you were wondering. Now, what I want to do that's spinning just fine. I'm looking at the teeth as it passes, and I'm not seeing any major issues. Everything is looking fine. I think I was just getting a little too ahead of myself. It happens. If you've never seen what a motor looks like taken apart, you're in luck. it off evenly. This is what the inside of a motor looks like. I wish it was a bit cleaner, but it is what it is. These are thrust washers, don't want to lose that. Is that picking up? I don't know. That bearing is shot. Yeah, this is looking fine for the most part. We're not going to say perfect. Definitely could use some bearings. This is what the inside of a motor looks like. You got all these different windings, and each one of those goes to a different wire connection. This is the other side. If I really wanted to, I could see how to remove this and all that kind of stuff. But I don't even have new bearings. So this is all just exploratory. Ultimately, what I think I'm going to have to do is swap motors. See if the issue follows the motor. I think that'll be the quickest and easiest way. Welcome back, everybody. If you could tell from that previous clip, swapping the motors, the issue followed the motor. Which means a couple things. One, you guys are around. One, there could be resistance in these connections that go to the armature inside. That could be why these wires are getting hot. Or the encoder, which is this one right here that goes all the way up to here, that encoder could be bad. If I wanted to, I could... Why are you zooming? Stop that. I could install this back into the unit and then do more testing to see if it's the wires or the encoder. But either way, it's going to need a new motor. I've tried replacing just the encoder before, and it came back with issues. It's very, very hard and finicky to get just right. So that's just one of those things of, I don't recommend it. I recommend just, I don't know what fell. I recommend just a whole new motor. Yes, it's $1,500, I think, for like a reman. I haven't officially looked up the price, but we could spend $300 on a new encoder, have me install it, and then a month later it fail it back. We have to spend the $1,500 anyways. So yeah, that's gonna conclude this video on this unit for now. Once we get the motor and I install the motor, I'll bring you guys back for a part 2. But that's gonna be it. Don't forget to like, comment, and subscribe. Catch you guys later. Deuces.